Hello, so my name is Siti Haja and I will be explaining the server configurations as well as the testing in Cisco for the dual stack network. So first of all, the web server. So for the web server, we have a default gateway and the DNS server as well as unique IP addresses based on the date of birth of the location of where the server is in. And because the web server is in the dual stack network, then the IP address is based on my date of birth, 15th March, as you can see in the IP addresses that I assigned. And the DNS server is important because we are creating A and quadruple A records where we can allow the clients to type the domain server such as dns.test.com or webs.test.com instead of the IP addresses. And other than that, in the DNS server, we also configure the DHCP service where it will automatically assign IP addresses to PCs, and it can prevent manual configuration and also reduce errors, hopefully. Okay, so next up will be the email server. So as for the email server, I created 3 different users so that I can test the SMTP and also the POP3. So what is the SMTP and POP3? So SMTP is basically so that we can send the emails, and POP3 is so that we can receive the emails. So next up is the FTP server, which stands for File Transfer Protocol. So I created a user called admin and allowed each permission, which is read, write, delete, rename, and list. Essentially, enabling these allows files to be transferred across networks. So that is all in terms of slides. Now I will be testing the Cisco Packet Tracer, the web server. So as you can see here, in the domain web.test.com, we receive. So that is great. And I will also go to PC10, composing an email. As you can see here. And in the IPv4, they will receive, which is there. All right. So now we will go to the FTP test, which is, I already typed it out. But to prove it, I will quit. And yeah, so that is pretty much for my servers. So yeah, that is all from me. Thank you.
Hi, I'm Faustina, and today I will be talking about our wireless and radio setup. Okay, firstly, our wireless LAN was deployed using multiple access points for engineering, marketing, and also guest user. And then a radio server AAA was configured to provide centralized authentication. And then department user account were created and router 4 was registered at the radio client. And then users such as engineering, marketing, and also guest was created for access control. After that, now we will be talking about our LAN and radius configuration for our users. Okay, first we need to go to admin PC, and through that we can go to web browser and put in our WLC IP to enter our WLAN configuration setting. In there, we can create the WLAN that we want. Okay, as you can see in the picture, first, to add it, we need to put the name and also the SID. For example, in the picture, I have engineering. And after that, we just apply it. And after we apply, we also need to configure the other stuff. Okay, first we configure the security. In the security layer 2, we can configure the WPA and also the authentication key. In the authentication key section, we can also configure our password for the network. After that, we also need to configure the AA server. Okay, previously I already created the AA server in the WC configuration. So then we can just select it and then apply. And after that, last but not least, we need to also apply Flex Connect. So this will help that when a user want to connect to a certain Wi-Fi, they don't need to do it manually in setting. They can just go to PC wireless and choose which one they want to connect and put in the password, and they will be connected. Okay, next. Okay, after that, after we apply everything in the setting earlier, we just need to group them by group. Which you can see I created 3 different groups. So I will divide them by group. For example, engineering will go to engineering and so on for the others. Okay, that's it. Now that we are done with the configuration, now we just need to go to the PC that we want, go to PC wireless and select the wireless network that we want. For example, in the picture you can see engineering, so just choose engineering and input the password that we have configured earlier. Okay, now I'll be showing you the testing that I have done in the green area and also the pink area. Okay, first, as you can see in the green area, you can see that every laptop is connected to every respective LPT point. So this go to gas, this go to engineering, and this go to marketing, all via PC wireless. And you can also see the DHCP is also received by all the PC. Okay, here is for laptop, here for PC 11, and here for PC 10. And after that, we will also be testing for IPv4 ping. And here we can see I ping the ping area, I got a reply, so it means that the IPv4 is working. And after that, I will be also showing the result that I got from pinging the dual start server. Here you can see that I pinged everything and I also got reply from every server. Now I'll be showing the result that I got from the ping area. And here you can see that I pinged the green IP address and I got a reply. So it means it's also working on the ping area. Okay, that's all for me. Thank you.
Hi, my name is Damia and I will explain the router configuration used in our network. All routers were configured to support dual stack networking, which means they can handle both IPv4 and IPv6 traffic. To enable routing between networks, we implement dynamic routing using OSPF. OSPF-VT allows IPv6 networks to automatically exchange routing information between routers. Each router interface connected to a network was assigned an IPv6 address and enabled to participate in OSPF-VT. Once configured, then routers successfully form neighbor relationships and share routing information. This allows all IPv6 networks to communicate efficiently without using static routes. Overall, dynamic routing improves scalability, reduces manual configuration, and allows faster recovery in case of network change or failure. Next, this is how OSPF-VT is formed. Routing table and interface are participating in OSPF-VT, as you can see right there. So that's all for me. Thank you, and on to my next team member.
Hi, I'm Nadira and I will present my part. So objective of the project is design and simulate a high availability dual-stack network, implement IPv4 and IPv6, VLANs and dynamic routing, configure service wireless networks and radius authentication, and lastly verify end-to-end connectivity using Cisco Packet Tracer. So this is our network topology overview. So this is implemented network. IPv4 is implemented by Fazena, IPv6 by me. High availability core network is implemented by Damia. Dual-stack server network is by Haja. And lastly, wireless and radius network is implemented by Fazlina. So this slide summarizes our IPv4 addressing plan. So we use a unique subnet derived from a member's birthday. Next, we also implemented IPv6 addressing using our group member DOB. Okay, this is our topology and my part is blue network, blue area. And I will show you the blue PC command prompt is successful ping to dual stack server. Okay, that's all from me. Thank you.